Let's talk about problem 2. Question 1. Find the probability that x2 equals 1. And as for this question, we can use the total probability formula. And we can analyze the probability as probability x2 equals 1 equals the probability of x1 equals 0 multiply the probability of x2 equals 0 on the condition of x1 equals 0 and plus x1 equal the probability of x1 equals 1 multiply the probability of x2 equals 1 on the probability on the condition of x1 equals 1, so that it equals 0.2 multiply 0.4 plus 0.8 multiply 0.7, and the probability of x2 equals 1 is 0.64. So the second problem is find the probability of x3 equals 1. It is very similar to the first question, and we can use the same method. But the question 2 is a little bit complex because we should count the probability of x2 equals 0 first. So first we should count this probability. Like the question 1, similar, and we can know the probability of x2 equals 0 is 0.36. And there is another method is that we can use 1 minus the probability of equals to x2 equals 1 equals the probability of x2 equals 0 equals 0.36. This method is more easy. It's easier. So now we have the probability of equals. We have the probability of x2 equals 0 and the probability of x2 equals 1. So we can count the probability of x3 equals 1. And we can get the probability of x3 equals 1 is 0.592. And as for the third question, find the probability of x1 equals 0 on the condition of x3 equals 1. We can count this probability directly like this, and we can count them partially. First, we can count this probability. x1, x2, x3. We can know if x1 is 0 and x3 is 1, there are only two paths. The first one is like this, and the second one is like this. So we can count the probability now. The first path is like this. So we use 0.2 plus 0.6 multiply 0.3. 0.4. And the second path, we can use 0.2 equals 0.2 multiply 0.4 multiply 0.7. We plus this. So we can get the probability is 0.104. And the probability of x3 equals 1, we count this before. It equals 0.592. So we can get this probability is 0.176. And then the question 4, find the we should count this. We can make a matrix like this. And what that matrix means, 0.6 means the input is 0 and the output is 0. 0.4 means the input is 0 and the output is 1. And 0.3 means the input is 1, the output is 0. And 0.7 means the input is 1 and the output is 1. So if we want to count the probability of a lot of noise channel, we could multiply this matrix. So we should to count the matrix the power to n. We should count this matrix. So like this, we can to analyze a matrix A as like this. So now we should find the lambda 1 and the lambda 2. Yes, and we get there. Lambda 1 is 1 and lambda 2 is 0.3. And now we should to count the matrix P. The matrix P is like this. 1, 1, 1 minus a negative 3 P is like this. So matrix and the power to n is like this. But when n approaches to positive infinity, this is approaches to 0. So we can have we can change this matrix to this one and this number to 0, so that we can have the final matrix like this. So this one is the how we get the probability of getting 0. So the probability of xn equals 0 is this.